Hello students, myself is Parminder Singh from Prab Kripa classes. Our today's topic is probability part 3. After going through this course, the students will understand that probability is a fundamental concept in mathematics and statistics. It quantifies the likelihood of an event occurring. Probability represents a numerical value between 0 and 1. If we say that the probability of an event is 0, it means that the event will not happen or it is an impossible event. If we say that the probability of an event is 1, then it means that the event is sure to happen. If there is a probability between 0 and 1, something say 0.5, it shows the varying degree of likelihood of the occurring of the event. Probability axiom or probability bounds indicate that the probability of an event is always a value between 0 and 1, both inclusive. That is, the probability of an event cannot be termed in negative and it cannot be termed as more than 1. And the probability of an event is measured by dividing the number of favorable outcomes by the total number of possible outcomes. Further, the probability of happening of an event, if added with probability of not happening of the event, the sum total of both, that is the probability of happening of event and probability of not happening of the event, is always equal to 1. Whether it is predicting weather conditions, assessing the chances of winning a game, or while making the stock investments in the stock market, probability is an essential tool that helps us in making rational decisions in situations where outcomes are uncertain or unpredictable. If the weather conditions are such that there is the likelihood of chance and the meteorological department predicts that there are the probability of rain, then naturally we will carry our umbrella with us, or we may postpone going outside because we may not be having any vehicle. Similarly, in the cases of making investment in the stock market, we take into account the possibility of the or the probability that the price of the share will rise, or the probability of the likely risks which we may have to face after investing. Thanks for We may add that these are the details of the questions which you will learn or find out the answers of the same of all these questions. Now the question before us is, one card is drawn from a well shuffled deck of 52 cards. Find the probability of getting king of red color, face card, red face card, jack of hearts, spade, and the queen of diamonds. Before proceeding further, we must have the knowledge how many total number of cards are there, how many face cards are in the playing cards, how many owner cards are there, how many ace cards are there, how many spades are there, how many hearts are there, how many cards are of black color, how many cards are of red color, how many diamonds are there. So we will first have to answer these questions or understand these questions so that we may proceed with the answer of this question. So let us have an overview of the cards. First of all, there are four types of symbols on the cards. That is, one card may have heart, other may have diamond, other club or spade. That is, there are four types of suits in the cards, that is heart, diamond, club and spade. Then there are total 52 cards in the playing cards, out of which 26 cards are of black color. You can see here that 26 cards are of black color, 13 are this and 13 are this. Next, 26 cards are of red color. You can see here that 26 cards are black, 26 are red color. Next, out of these 52 cards, 13 cards are spades, which are 13 in number. Hearts, which are of red color, are also 13. Diamonds are also 13. They are of red color. Clubs are black color and they are also 13. To remember which type of cards are red or which type are black, we can remember it as HD. H stands for hearts, D stands for diamond. These are red color. CS means, you can remember it for understanding this concept. CS, you can remember it as computer science. C stands for club, S stands for spades. Clubs and spades are of black color, whereas HD cards, that is hearts and diamonds, are of red color. Next, from this picture, you will find that out of these 52 cards, 4 cards are ace. That is, in this cards, there is no card which starts from the digit 1. Instead of that, the cards have A symbol. These are 4 in number and these are called ace cards. These are 4 in number. Next, 2 to 10. These are 9 cards which have bearing on it 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 9 cards. These are spades. These are 9, which are digit cards. So there are 4 lines of these digit cards. These cards are 36 because there are 4 rows. Then jack, queen and king. These are called face cards because they have a face on it. This is the face of a jack. This is queen. This is queen. This is king. So these are face cards. These are 12 in number. 4 are jacks, 4 are queens, 4 are kings. You will also observe that out of these face cards, 2 are black, 2 are red. You can see here that this king is black in color, this king is also of black color. Here, these 2 are of red color. In the same way, 2 jacks are of red color, 2 of red color. 2 queens are of black color, 2 of red color. In the same way, with the ace cards, 2 are of red, 2 are black. Next. Now, what is the owner cards? These 4 ace cards plus 12 face cards constitute the owner cards. That is, the face cards plus ace cards are known as owner cards. Now, to sum up, you can see that total cards are 52, out of which 26 are black in color, 26 red in color, 13 are spade, 13 are club, 13 are heart and 13 are diamond in color. you can also see that there is some sort of similarity between spade and heart cards. That is, if we place the hearts in the upward position, lower side upward, and there is some stand below it, it becomes spade. You can further see that face cards, we have seen that there are 12 face cards. 6 are black color, 6 are red color. Face in the face cards, 4 are queen, 4 are king, 4 are jack, and 4 are ace cards, and together face cards and ace cards constitute honor cards. And out of these 16 honor cards, 8 are black in color, 8 are red in color, and the cards which have bearing on it 2 to 10 are called digit cards. These are 36 in number, out of which half are black, half are red in color. We hope we have understood how many cards are there, how many suits of cards are there, how many face cards are there, how many ace cards, how many honor cards. You have understood the same. Now we will proceed with answering the question. Now what is the question? One card is drawn from a well shuffled deck of 52 cards. That is, out of these 52 cards, find the probability of getting a king of red color. Now you understand that we have seen that in the cards, kings are 4, 4 king, 4 queen, and 4 are jack. So out of these 4 cards, 2 are black in color, 2 are red in color. We have already learnt about the same. So the total number of outcomes or total number of cards oblique outcomes are 52. So the number of favorable outcomes, that is red color king cards, how many are there? We have find out that these are 2. So what is the probability of a king of red color? 2 over 52, 1 over 26. This is the first part of the question. We can also add that in all these questions we will use the formula probability is equal to number of favorable outcomes. Number of favorable outcomes here stands for the number of cards for which we have to find the answer, and it will be divided by the total number of outcomes. Total number of outcomes means the total number of cards for which we are counting. If we are to find out the answer of red color cards, we will add it here and the total number of cards will be mentioned here. Now the next is find the probability of getting a face card. We already have learned that the total number of outcomes or the total number of cards are 52. Now here the number of favorable outcomes, we have learned that out of these 52 cards, there are 12 cards which are face cards. How? We had learnt that 4 are king, 4 are queen, and the 4 are jack cards. So number of favorable outcomes are 12 and the probability of getting a face card is 12 over 52. We will divide both by 4. So this is the answer of second part, probability of getting a face card. Next is the probability of getting a red face card. We have learnt that face cards are 12, out of which 6 are black, 6 are red. So we will not now write total number of outcomes. You can write it yourself. We will proceed with the answer of this question. Probability of red face card. Here we will write the number of favorable outcomes. The number of favorable outcomes are red face cards. These are 6. It will be divided by the total number of cards. These are 52. Now we will divide both by 2. So the answer before you is 3 over 26. Now we proceed with the further. The probability of getting a jack of hearts. We had learnt that there are 4 jacks cards, out of which one is diamond, other is HD, you can remember, other is heart, other is spade, and the other is CH, that is this club card. So there is only one jack of hearts. So what is the probability of jack of hearts? How many cards are jack of hearts? You can find that it is only one. So what is the total number of cards? These are 52. So this is the answer before you. Now the next is find the probability of getting a spade card. We had learnt that there are 52 cards and out of which 13 are spade cards, 13 are club cards, 13 are diamond cards, and 13 are heart cards. So what is the probability of getting a spade? So number of spade cards are 13, that is the number of favorable outcomes are 13. It is to be divided by the total number of possible outcomes. Total number of cards are 52. So the answer before you is 1 over 4. Now we proceed further. Now we have to find out the queen of diamonds. We had learnt that queen cards are 4, out of which one is diamond, other is heart card, other is spade card, and the other is club card. So what is the queen of diamonds? You can see that there is only one card which is queen of diamonds. So probability of queen of diamonds, though I am giving very in short, you have to mention number of favorable outcomes divided by total number of outcomes. However, we are solving the question as you have understood the formula for the same. So queen of diamonds is 1. It is to be divided by the total number of outcomes, that is the total number of cards, which are 52. So this is the answer before you. Now the question before us is 5 cards, the 10, jack, queen, king and ace of diamonds are well shuffled with their face downwards. One card is then picked up at random. What is the probability that the card is queen. So first of all, we understood the question. We understand the question. There are 5 cards. These cards are there. 10, Jack, Queen, King, and Ace card. These are the 5 cards which are having which are diamond cards. That is the red color diamonds is there. These are the 5 cards. These are have been shuffled and their face is in downward position. And we pick up at one of the cards at random. What is the probability that the card is queen? So here the total number of outcomes, possible outcomes. Total number of possible outcomes means the total number of cards. How many cards are there? 1, 2, 3, 4, 5. Total number of outcomes or total number of cards. These are 5. Now the next is number of favorable outcomes. It means the number of queen cards. How many queen cards have been given? That is the queen card which has diamond. It is only 1. Out of these 5, only 1 card is queen card. So what is the probability of getting a queen card? It is number of favorable outcomes, that is the number of queen cards which are diamond, divided by the total number of outcomes. There are only 5 cards have been given to us in the question. So it will be 1 over 5 probability of getting a queen card. Now the next part of this question. If the queen card is drawn and put aside, first of all we write what was the question. 10, Jack, Queen, King and Ace, which were diamond cards. So these were the 5 cards which were given. So now what is written? If the queen is drawn, that is this card has been picked up and put aside. The card has been placed on another side. So what is the probability that the second card picked up is an ace? That is, this is the first turn that we have drawn queen card and put it aside. Now if we pick up queen card and put it aside, then total number of outcomes or the total number of cards which are balanced are 1, 2, 3, 4. Total number of outcomes are 4. Now the number of favorable outcomes, we have to find out what is the probability that the second card picked up is an ace. Probability of getting an ace. Ace cards are 1. You can find it here that out of these balanced 4 cards, the ace cards is only 1. So what is the total number of outcomes? There are only 4 cards balanced because the queen card has been put aside. So it is to be divided by 4. So the probability of getting the ace card is 1 over 4. Now the next part of the question. What is the probability of getting a queen? Probability of queen. Now from the question we had learnt that we had already put the queen aside. There is no queen left in these 4 cards because these cards are only 10, Jack, King and Ace. So we have no queen card balance. So the probability here we will write 0 and it will be divided by the total number of outcomes. This is 4. So the probability of getting the queen card is 0, because we have already put aside the queen card and the balance cards are not having any queen card in it, so the probability of getting a queen card is 0, because when queen card is not present in the cards, we cannot get the queen card. Now the question before us is 12 defective pens are accidentally mixed with 132 good pens. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. What is the question? That there are some good pens and the quantity of this is 132. There are some defective pens. Defective pens are 12. Number of good pens, number of defective pens. So how many total pens are there? The total pens are 144, or we can also write it as total number of possible outcomes. That is, if we start picking one pen turn by turn, there will be 144 instances that we can pick up a pen. Now what is the question? One pen is taken out at random. From out of these 144 pens, we are to pick up one, because by looking at the same, we cannot tell that this pen is defective or is in working condition. Determine the probability that the pen taken out is a good one. So here the number of good pens or the number of favorable outcomes are, here we will mention good pens. These are 132. So the probability of getting a good pen is equal to number of favorable outcomes. These are 132. That is the number of good pens will be taken above, and it will be divided by total number of pens or total number of possible outcomes. Here we will divide it by 2. It will come 66 over 72. We will again divide it by 2. It will come 33 divided by 36. We will again divide it by 3. It will be 11 divided by 12. This is the answer before you. Now the question before us is, a lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? You must understand this question very carefully, because here the bulbs given are lot of bulbs. That is, it does not mean that the 20 bulbs are good and 4 are defective and the total bulbs will come as 20 plus 4 24. This will be wrong. Here it is given that lot of bulbs, that is the number of bulbs in the lot. These are 20. We can write it as number of bulbs in lot. That is, there is one packet and which has total 20 bulbs. You can remove it. Then there are, out of these lot of 20 bulbs, some bulbs are defective. Number of defective bulbs, it is 4. So when out of this 20 bulbs 4 are defective, then other bulbs might be good. The number of So the number of good bulbs are when we subtract 4 from 20, the answer is 16. So now, what is the probability that the bulb is defective? So here, the total number of outcomes are, or the total number of bulbs are, which are in the lot 20. So the number of favorable outcomes, here the favorable outcomes means the number of defective bulbs. The number of favorable outcomes means the number of defective bulbs, in respect of which we have to find the answer. The number of defective bulbs are here 4. So the probability of getting a defective bulb is defective bulbs, number of defective bulbs divided by total number of bulbs, or number of favorable outcomes divided by total number of outcomes, and it is 1/5. So next part of the question, suppose the bulb drawn in 1 is not defective. That is, if we draw a bulb out of these 20, the bulb is, suppose it is good and it is not replaced, that is, we do not put any other bulb in its place. Now one bulb is drawn at random from the rest. What is the probability that this bulb is not defective? Now what is given? Here one bulb which is not defective, that is, which is not defective, that is good bulb. Here one bulb which is not defective, that is the good bulb, has been drawn and not replaced. So the number of balance good bulbs, we had learnt that there were 16 good bulbs. So now the number of balanced good bulbs are 15. The number of defective bulbs, these remain the same. Defective bulbs are 4. So now total number of bulbs are, or the total number of outcomes in this position when one bulb which is good has been drawn and not replaced are 15 plus 4, it is 19. So what is the probability that the bulb is not defective? That is, here we will calculate the probability that the bulb is not defective. It means here we will have to mention the number of bulbs which are in good condition. So here the number of bulbs which are in good condition are 15, and the total number of outcomes, or the total number of bulbs in the new scenario, are 19. So this is the answer before you. We can also write in here that probability of getting a good bulb. Now the next question is, a box contains 90 discs. These are 90 discs, 1 to 90, which are numbered 1 to 90. That is, on each disc numbers have been given on the back side, 1 2 3 4, in the same way up to 90. One disc is drawn at random from the box. That is, in the box there are 90 discs, and on all the discs the numbers have been mentioned, and we draw a disc at random. What is the probability that it bears a 2-digit number? What it means? Suppose these are the digits 1, 2, 4, 5, 6, 7, 8, 9, 10, and then 11, 12, 13, 14, and all these are up to 90. So here we have to find out the probability that it bears a 2-digit number. That is, these are the digits up to 9, which are a single digit number, and from 10 onwards up to 90, all the discs have the number which are in 2 digit, that is 10, 11, 12, 13, 14, 15, 16, and so on up to 90. All the discs are 2-digit number. So here we will mention total number of possible outcomes, or the total number of discs are 90. Now the number of favorable outcomes, or the discs having 2-digit number, all the discs which are having 2-digit number. So if we, out of this 90, we deduct 9 which have single digit number, the balance are 81. So this is the number of favorable outcomes. This is the 81. So what is the probability of getting a 2-digit number disc? So here we will mention the number of discs which have 2-digit number, that is the number of favorable outcomes, and it will be divided by the total number of discs or the total number of possible outcomes. So we will divide both by 9. It will be 9 over 10. So this is the answer of the first part of the question. So now the next part is find the probability that it bears a perfect square number. For the purpose of easy understanding of the question, we have here drawn a table so that you can easily understand the answer of the question. Here it is given that we have to find the probability that the disc bears a perfect square number. That is, the number which is appearing on the disc should be a perfect square number. We will start from 1. Once, if we make the square of 1, it is 1. If we make the square of 2, it becomes 4. If we make the square of 3, it becomes 9. If we make the square of 4, it becomes 16. If we make the square of 5, it becomes 25. If we make the square of 6, it becomes 36. If we make the square of 7, it becomes 49. If we make the square of 8, it becomes 64. 9, it becomes 81. If we make the square of 10, it becomes 90. After that, we cannot go. So these are the discs which bear a perfect square number. 1 is the square of 1, 4 is the square of 2 into 2, 9 is the square of 3 into 3, 16, 4 into 4, 5 into 5, 6 into 6, 7 into 7, 8 into 8, 9 into 9. If we make the square of 10, it becomes 100, and it is out of our range of 90 discs. So we count the same: 1, 2, 3, 4, 5, 6, 7, 8, 9. So here the total number of outcomes, or the total number of discs, are 90. number of favorable outcomes, that is the number of discs having a perfect square number, are 9. Probability of disc having a perfect square number is equal to 9 over 90, that is 1 over 2. This is the second part of the question. Now next, what is the probability that the disk bears a number divisible by 5? Here 5 is divisible by 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All these are divisible by 5. If you count the same, it will be 90. In other words, we can also divide 90 by 5 and it will be 18. So if you also count the same one by one, all these, it will be 18 in number. So probability that the disk bears a number divisible by 5 is equal to number of disks having a number divisible by 5 are 18. That is the number of favorable outcomes are 18, which we have counted here, all these where we have marked in circle or in this position. So the total number of outcomes or the total number of disks are 90. So it is 1 over 5. This is the answer of the third part of the question. Now the question before us is, a child has a die whose 6 faces show the letters as given below. These are the letters. The die is thrown once. What is the probability of getting A and D? Normally, the die. What is the meaning of die? Die has been shown this. If it is a single piece, then it is known as die. When there are more than one pieces of the die, they are known as dice. So there is no difference between die or dice. These are only the difference between the two is only singular and plural. Die is singular word of a particular item and the dice is the plural of the same. Normally the die or dice has these type of dots on it, that is 1 to 6. But here the die has different things appearing on it. Here the letters are appearing on it. Please go through the question carefully. You will observe that the letters written are A, B, C, D, E and A. That is, A number is appearing on the die twice. So we will now solve the question. Total number of outcomes. The total number of faces are 1, 2, 3, 4, 5, 6. 6. Now we will solve the first part of the question. What is the probability of getting A? Number of favorable outcomes, that is the number of faces having letter A. Two faces have the letters A on it. So the number of favorable outcomes are 2. So what is the probability of getting A? It is 2/6, or we get the answer 1/3. Now the next part, here the number of favorable outcomes are, in this question D face is appearing only once, so the number of favorable outcomes are 1. So what is the probability of getting a face with letter D? So the number of probability, here we will write the number of favorable outcomes, that is the number of faces having the letter D. It will be divided by the total number of faces or the total number of outcomes, which is 6. So this is the answer of the second part. Next part, next question. Suppose you drop a die. As already told that die and dice are the refer to the same object. Die is a singular word, whereas dice is the name of the same object, but it is plural of the same object. Suppose you drop a die at random on the rectangular region shown in the figure. That is, if you have a die, you drop it on the rectangular figure, what is the probability that it will land inside the circle? That is, it will land here with a diameter of 1. Here, from here to here, it is known as diameter, which is 1 meter. So now we are to first find out, we will write what is given. Diameter is given of the circle. Diameter given is 1 meter. You know that the radius is 1/2 of the diameter. So diameter divided by 2. So 1/2 meter, that is 0.5 meter is the radius. So to find out the probability of landing of the die inside the circle, here we will have to find out the probability of landing dice inside circle. How will we calculate it? Here the area of the circle will have to be taken on the upper side. So what will be the on the lower side? Total area of the total area, that is the area of rectangle. Here it will be known as favorable outcome, this area, and this total area will be known as total number of favorable outcomes. We normally use the formula number of favorable outcomes divided by total number of outcomes. Here, because the area has been given, here we will find out the favorable area divided by total area. So to find out the area of the circle, its formula is pi r square. Pi r here stands for 0.5. 0.5 into 0.5. So what is the area of the rectangle? Area of rectangular region, it is length into breadth. 3 into 2, it is 6. So here we will write area of circle pi into 0.5 into 0.5 divided by total area, it is 6. We can also write it as pi into 5/10 into 5/10 into 1/6, because here we have removed the dot before 5. So here it becomes pi into 25 over 600. 10 into 10, 100 into 6, 600. So we can also write it as pi. Here 25 will cut 600 by 24. Pi over 24. So this is the probability of landing of dice inside the circle. This is the answer, pi over 24. Now the question before us is, a lot consists of 140 ball pens, 144 ball pens, of which 20 are defective and the others are good. Noori will buy a pen if it is good, but will not buy it if it is defective. The shopkeeper draws one pen at random and give it to her. What is the probability that she will buy it? So now what is given? It is given that the total number of pens are 144, out of which some pens are defective. Number of defective pens are 20. And the others are good. So now the number of good pens are 124. If we deduct 20 from the total lot of 144, the good pens will arrive at. So the number of good pens are 124. So now what is written? Noori will buy a pen if it is good. Noori will buy a pen if it is good. So now we have to calculate probability Noori will buy pen. We have to calculate this. So here, what is the probability of Noori buying the pen? Noori will buy the pen if it is good. So here, the number of favorable outcomes are the number of good pens. The number of good pens are 124. And what is the total number of pens or the total number of possible outcomes? These are 144. We will divide both by 2. It comes 62 divided by 72. We again divide it by 2. It becomes 31 over 36. So Noori will buy pen. Its probability is 31/36. This is answer of the first part of the question. So now, what is the probability that it will not buy it? Here we are to find probability Noori will not buy the pen. So here, what is the number of favorable outcomes? Here the number of favorable outcomes is to be divided by total number of outcomes. This is the formula to calculate the probability in any question. So she will not buy the pen. Noori will not buy the pen if it is defective. So the Nuri will not buy pen. Its probability is to be calculated by the number of defective pens. The number of defective pens are 20. It is to be divided by the total number of outcomes, total number of pens. It is 144. So here we will divide both by 4. What is it comes? It comes 5. When we divide 144 by 4, let us see what comes. It comes 36. 5 over 36. This is the probability that Nuri will not buy the pen. Now the question before us is, a game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result, that is 3 heads, 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. So what is given in the question, that there is 1 rupee coin and it is tossed 3 times. So suppose there is 1 rupee coin and it is tossed 3 times. This is the first time, this is second time, this is the third time. So what are the possible outcomes? It may be possible that on all the 3 occasions he may get head. Then in the second time, it is possible that on 2 occasions he gets head and tail in the third. Then in the third time, when the 1 rupee coin is tossed for 3 times, there may be head, tail, head. And then on another occasion, there may be tail, head, and head. Then on the 5th time, there may be tail on all the 3 occasions. Then there may be tail, tail, and head. Then tail, head, tail. And then there may be head, tail, and tail. So these are the possible outcomes when a 1 rupee coin is tossed 3 times and many times. So these may be some possible outcomes. So here, what are the total number of outcomes? Let us count the same. 1, 2, 3, 4, 5, 6, 7, 8. These are the 5 possible outcomes. So now Hanif will lose the game. We are to find out probability. Hanif will lose the game. Here we are to find out the number of favorable outcomes. It is to be divided by total number of outcomes. So what are the favorable outcomes? That Hanif will lose the game. Hanif will lose the game. It is given in the question that Hanif wins if all the tosses give the same result, that is 3 heads and 3 tails. That is, if there are 3 heads, he will win. If there are 3 heads, tails, he wins. That is, on these 2 occasions, he will win the match. So out of the total 8, he will win only twice, when there is head and tail on all the 3 times. So the number of favorable outcomes are except these 2. The other are 1, 2, 3, 4, 5, 6. The number of favorable outcomes are 6. When he will lose the game. Number of times Hanif will lose the game are 6. It will be divided by 8. So the answer before us is 3 over 4. This is the probability. Now the question before us is, a die is numbered in such a way that its faces show the numbers 1, 2, 2, 3, 3, 6. it is thrown 2 times and the total score in 2 throws is noted. Complete the following table which gives a few values of the total score on the 2 throws. First of all, we must understand the meaning of die. It is this object which we use in games. Die is the singular word dice. If there is only one single piece, it is known as die, whereas if there are more than one pieces of this, it is known as dice. So there is no difference between die or dice. So now here it is given that dice or die has the numbers 1, 2, 2, 3, 3, 6. Normally the dice has these types of appearances on its face which range from 1 to 6. But here in this dice, the numbers have been changed. Normally it may be written 1, 2, 3, 4, 5, 6. But here the numbers have been changed. Now this dice is thrown 2 times and the total score in 2 throws is noted. How it is noted? We understand it from the table. Suppose it is thrown first time, it comes 1. Then it is thrown second time, it comes 1. So the total of 2, 1 plus 1 has been given. Suppose here die is thrown once, it comes 2. And the die is thrown for the second time, it comes 1. So here the total of these 2. In the same way, if the die is thrown for the first time, the outcome comes 3. And if it is thrown for the second time, it comes 1. And the total of 2 is given. So in this way, we have to complete the table. Here, these 2 rows are complete. We have to complete the next. So 2 plus 1, 3, 2 plus 2, 4, 2 plus 2, 4, 2 plus 3, 5, 2 plus 3, 5, 2 plus 6, 8, 3. We have to add 3. 3, 1, 4, 3, 2, 5, 3, 2, 5, 3, 3, 6, 3, 3, 6, 3, 6, 9. 3 plus 1. Here we have to add 3 to all these. 3 plus 1, 4, 5, 5, 6, 6, 9. Here the table has been completed. Now we will proceed further. What is the probability that the total score is even? We have now completed this table and shown it in full form. What is the probability that the total score is even? Now, first of all, we must understand what is the meaning of even. Even numbers are those numbers which are divisible by 2. Completely divisible. The last digit of an even number is either 0, 2, 4, 6 or 8. Last digit of the even number may be any one of these 5. 0, 2, 4, 5, 6, 8. Even numbers are those which are completely divisible by 2. Now, we can calculate the probability of getting an even number. So, first of all, we will find out the number of favorable outcomes. Number of favorable outcomes means those numbers which are even. We will find out the even numbers 2, 4, 4, 4, 4, 8, 4, 4, 8, 4, 5, 5, 6, 6, 9 is not a even number. 4, 5, 5 not an even number. 6, 6, 9 not, 7 is not an even number, 8, 8 and 12. We calculate the even numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 11, 13, 14, 15, 16, 17. No. We again calculate, there seems to be some mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. These are 18. So the number of favorable outcomes are 18, where there are even numbers. And this is to be divided by the total total number of possible outcomes. Total number of possible outcomes are here, these are 6 and it has been multiplied 6 times. So 6 into 6, 36. You can also count the same. These are 6 and there are 6 rows. 6 into 6. These are the total number of possible outcomes. So here the probability of getting an even number is, total score is even. Probability of total score is even is 1 over 2. This is the answer, that the total score is even. Out of the 2 throws, the total score is even. Next is, what is the probability that the total score is 6? We find out the same. 2, 3, 3, 3, 4, 4, 7, 3, 4, 4, 5, 5, 8. Here we have to find out only where the total score out of these 2 throws is 6. 3, 5, 5, 8, 4, 5, 5, 6. This is 6. This is 6. 9, 4, 5, 5, 6. Here it is 6. So the probability that total score is 6 is number of favorable outcomes. Favorable outcomes here are 4 out of the total number of possible outcomes. Here the answer is 1 over 9. It is the answer of the second part of the question. Now, what is the probability that the total score is at least 6? What is the meaning of at least 6? At least 6 means equal to or greater than 6. That the item or the total score must be 6 or more than 6. At least 6. Equal to 6 or more than 6. So here the probability total score is at least 6 is equal to number of favorable outcomes. Number of favorable outcomes we will find out. We are not to count this because first line, not to count this because these are the only for which are appearing on the die. These are those numbers which were appearing on the dice. So we will start from here. Total score is at least 6. Here it is the first. Here it is more than 6. It is also more than 6. It is more than 6. 4, 5, 5. Is it equal to 6? 6, 9, 4, 5, 5, 6, 6, 9, 7, 8. All these are more than 6 or equal to 6. More than 6. These are all. So how many numbers are equal to or more than 6? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this is the 15. So the probability that the total score is equal to or more than 6 is equal to 15. Here we will mention the number of possible outcomes. It is to be divided by the total possible outcomes, which is 36. Here we can divide it by 3, 5/12. This is the answer before you. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.